Welcome to the complete Python networking course. My name is Martin Yanev, a master's degree software engineer with solid experience with all types of programming languages. As part of my work, I design, test, and integrate complex software solutions in United States. If you want to become a software networking engineer or system administrator, then this course is the right place for you. Here you will learn all Python libraries for networking and web programming. And instead of learning from complex theories and equations, here you learn from practice. You write plenty of networking scripts using PyCharm and the terminal Python mode. In this course, you learn Python for network programming, how to extract data in different formats, and request and retrieve web resources. You adopt a variety of protocols, and you modify systems over the web with the DNS and IP networking. We will start from very basics with the Python 3.9 installations, and then continue to more advanced networking topics. Please make sure to subscribe my channel for more free coding courses. But why learning Python for networking? Well, see, as the software development expands and also in general, all the specialty related to computers will expand with about 22% in the next 10 years, the networking is quite important. Because more computer systems are built, so we need to learn how to program those computer systems and make the connection between them more easy to assess. And for that reason, this makes this course and the information here of a key importance, especially if you want to work as a software network engineer or system administrator. In fact, I can tell you that most of the information technology jobs out there are requiring some sort of understanding of what is network and how you can assess it. And this is what you will learn in this course. Python is actually the most useful tool for assessing different systems over the network and extracting information from them and then analyzing it. I'm uploading completely free programming courses every week, so make sure you hit the subscribe button to get more coding skills. You can find the complete 12-hour course on the link in the description. Hello everyone, welcome to the first section of this course. My name is Martin Y, and in this course I'm going to be teaching you in how to use Python for network programming. The course will actually concentrate on writing programs for networks that are using the Internet Protocol or the IP. But why we're going to concentrate specifically on the IP but not on the other type of protocols? Well, the reason is that the IP and the TCP protocols are the most widely used in today's networks. So these protocols are used by basically anything in internet, and by learning the TCP IP protocols and how to assess the different devices by IP addresses, you can basically learn how to connect and use basically any device out there on the web. So in this section we're actually going to cover an introduction to TCP and IP networks, which we already started, the main concepts of the protocols and the problems that the protocols can actually solve. We'll cover addressing. We're going to work with Flask and HTTP in order to create RESTful web application and actually use it and show how these applications work. And we're also going to do the interacting Flask and the connection with the SQL database. So basically this section will have two major subsections. The first one will be the introduction to the TCP IP networks, and we're basically going to talk about the essential network concepts so we're on the same page when using the softwares afterwards and when trying to connect to different devices through internet. We will talk about how IP allows data transfer between different networks, and basically how the TCP and IP provides us with services to help develop network applications. So depending on your background, and for example if you are already familiar with what IP address is and what the TCP protocol is, as well as the user datagram protocol, then you might consider skipping this section, which I actually don't advise you, because even though you have some knowledge about all these topics, it is a good me and you that we're on the same page, so we both understand what we're talking about in the sections afterwards. So the second part of this section will actually talk about how the network programming is achieved by Python. So in there I will provide you an overview about the basic network elements and principles. We're going to discuss how Python supports the network programming, and we're going to talk about different libraries that Python uses for that aim. And finally, I'm going to show you a very simple to use tool which is called Wireshark, that can basically explore protocols in the network that is usually used for programming diagnostics. We're also going to install finally the PyShark module in our devices and basically see how Wireshark can be accessed with PyShark from Python. So to complete this course, I would assume that you already installed Python, which is described in our initial sections, in our first sections where I talked about how to install basically Python. And throughout the course, we're of course going to install some other softwares in order to use them on our computers. That's it, guys. Thank you very much for watching this overview lecture, and in the next lecture we're going to talk about the IP and the TCP protocols. Thanks for watching. Hello everyone, and welcome back to the course. As this is the first section of that course, here we're going to actually offer some videos and lectures that are talking about the essentials about the networking concepts, and we're going to focus strongly on the TCP and IP stack. It is very important firstly to mention that this section and all the sections after that are based on the Internet Protocol version 4 and version 6. So if you don't know what this is, basically Internet Protocol version 4 is the database of all IP addresses that are possible to be taken in Internet, and IP version 6 is created due to the fact that IP version 4 already starts running out of IP addresses, even though there were billion possible addresses with the IP version 4. But now, since they are taken due to the explosion of internet, now we're also using the IP version 6 IP address type. So the TCP and the IP set of protocols are designed to work together to provide an end-to-end transmission of messages across different interconnected networks. So usually we say that the TCP protocol works in the transport layer, while the IP protocol works on the network layer. So the TCP is responsible for creating connections through a data flow. And this is because this process guarantees that the data delivered to the destination is without any errors, and it is delivered basically in the same order in which we send it out. On the other side, IP is responsible for sending and for receiving data blocks. So the aim of the IP is just to find the right IP address or the right route to a system, but it pretty much doesn't guarantee that the data actually is reaching the right destination. And for that reason, we are usually using the TCP and the IP at the same time. So actually, let's talk about the similarities about the TCP and the IP. Basically, both of the protocols are used to solve the transmission over data generated in a network and aim to be transmitted internally or externally. The union basically of those protocols is done to ensure that information always arrives on the best route and on the correct destination. So let's talk now about the protocol stack and the different layers incorporated within this protocol stack. So basically the protocol stack has exactly 4 layers. The first one is called the application layer, and this layer pretty much manages the high-level protocols, including representation, coding, and some dialog control issues. It handles everything that is related to applications. So an example of application layer would be Telnet, which we all use, for example, to connect to certain devices that are, for example, connected to a router which actually has an IP address. And let's say to that router you can connect more than one device, right? So these devices are going to be into the application layer. Then we have the transport layer, and this layer basically handles the quality of the service, the reliability, the control of the flow, and the errors as well. So one of those protocols is exactly the TCP protocol, which aims to provide reliable network communication and some order of the connections. So the transport layer could be either with TCP protocol, which gives an ordered connection to a device, on or UDP, where there is no ordered connection, which means that when we send messages, there is no guarantee that they are going to be received in the same order that they've been sent. Next one is the network layer, and basically the purpose of the network layer is to send packets from the source to any network and make these packets to reach destination regardless of the route that they actually use in order to get there. And the final layer is called the network access layer, and this is also called the host to host network layer. It includes the WAN and the WAN protocols. They are also known as link layer or data link layers. So we can say that the network access layer is basically the interface layer to the current network hardware. So if we check the next diagram, we can actually see the different layers and what they basically control. So on the top level, as you can see, we have the application layer with the SMTP or the telnet commands in order to access devices. Then we have the transport layer. Then we have the network layer, which is the IP address basically. And finally we have the network layer, which is, for example, the wireless or the WAN, let's say. So the network layer is basically when you connect to internet, then we get the network, which is the IP addresses, then we get the transport of that IP address, and finally we reach our application. This is basically how works everything that is related to connecting to some service on the web or locally. And usually the IP address is the most important protocol in the network. And even though it's the most important, as we already said, the IP address does not provide any reliability, flow control, or error recovery. And this is because IP is simply a way in order to name a device or service on the web or locally. So the protocol that is basically responsible for the reliability and error recovery is the TCP protocol or the UDP protocol. Both of them, they're used in the transport layer. So when you want to send some data over network, this is called sending an IP diagram. So this basic unit or this diagram is transmitted from one site through the TCP IP network to another site. Also, the application layer is basically the layer where the user interacts with the computer, where actually the services occur or the action occurs with the actual system that we use. And even though if you access browsers over internet, we actually do use them in order to connect to the application layer or to communicate with the application layer. So we log into the browser and then we communicate with the actual service that is somewhere around the world. On the other side, if we want to access a remote document, we can use the HTTP protocol, which is basically everything that we see in the beginning of the name of each website. Each time we request a communication of this type, the browser actually interacts with the application layer. So it actually serves as an interface between the user application and the protocol stack, and finally provides a communication with the lower layers. Hello everyone, today we are going to talk about the transport layer that we covered in the last lecture, and actually we're going to divide it into two topics, the UDP protocol and the TCP protocol. So the UDP protocol is non-connection oriented. So for example, if we have a machine A that wants to send an information to machine B, and here I have machine B, the flow from A to B is unidirectional. So A don't need to notify there is no notification when we are sending anything to machine B. Okay, so A just decides to send something to machine B and the machine B is not aware of that. So on its side, B don't actually need to send a confirmation to machine A. Okay, so here we don't have any confirmation, and basically the UDP simply sends information from one user to another without the need to have any confirmation. Okay, so it pretty much just sends information and the chance for errors are way less. So the reason for that is because when you use the UDP protocol, you're pretty much not allowed to transmit information that is related to the sender. And for that reason, the recipient will not be able to know which sent the data. The only thing that the receiver would know is their IP address. So if you look at the main properties of the UDP, we can say that the UDP is unreadable. So there is no concept of packet transmission, for example. So when a UDP packet is sent, it is not possible to know whether the packet has reached its destination or not. Also, the UDP is not ordered, which means that when we send messages, we don't actually receive the first send message first, and so on. So also the diagrams mean that the integrity of the packet delivery is done individually for each packet and can actually be the only way to check if package is delivered correctly by simply checking it. Finally, due to the fact that the UDP doesn't require receiver confirmation, this means that the application is actually quite lightweight comparing to the other transport protocols. And one of the main reasons also is that the UDP has no error recovery. So it is very possible that if we receive an error, that the message is simply don't send and we're actually not going to get a notification for that. On the other side, we can have the TCP protocol, which has a few advantages as compared to the UDP protocol. So when using the TCP protocol, the connection is actually ordered. So if I make here the same example with the machines, for example, something wants to be sent from machine A to machine B. So here is B. So let's say we want to send data to machine B. I will write here data. So if you want to send data from machine A to machine B is actually getting first informed that the data is going to arrive to it, and it actually confirms back to machine A that it is okay for receiving this data. Okay, and after machine B is okay, then from A we actually send the actual data to machine B. So the control of this data is based on the mathematical equation and allows you to verify that the transmitted data is actually sent. So for example, if there is a reason for which the message that has been sent was corrupted, we can easily fix that by the automatic feature of the TCP to allow the sender to send the message again upon error of this sending. And for that reason, the TCP protocol is pretty much preferred and is one of the main protocols in the transport layer, and is used with the IP in order to transmit data over the web. So in real life, when you actually want to send data over internet, it first uses the IP protocol. It binds the IP diagrams or the units that you are going to send, and then it knows in advance that the protocol used is going to be the TCP. And the other reason for preferring TCP is that, for example, if you are sending a message between two machines, they can communicate properly and know the status of the message that is being transmitted between them. So as the main properties of the TCP, we can say that it is reliable, and this is because the TCP protocol has the ability to manage attempts that can be made for sending a message if, for example, a packet is lost or corrupted and so on. Also, the messages that has been sent are sent in order, and for that reason this method is quite ordered. And the final thing, due to the complexity of that method, the TCP is quite heavyweight, And this is pretty much due to the fact that the TCP has the ability to verify that the connection can be established through the socket even before a packet can be sent through the web. So if we finally compare the TCP and the UDP, we can say that the main difference, actually the most major difference between the UDP and the TCP is that the TCP is ordered for connection. It simply sends messages and the receiver receives them. So the main differences between these two methods are, for example, the difference in the data transfer. Obviously on the TCP it is ordered, while on the UDP it's not dedicated to point-to-point connection, and there's no guarantee that the receiver actually receives the data. On the other hand, the TCP is actually way more reliable because it manages to recognize the messages were sent and received by the receiver, while the UDP on the other side cannot basically verify in any physical way that the message has been sent. Also, regarding the connection, the TCP is a protocol, actually has a real connection from one device to another, and they need to be connected in order to be able to send information in both ways. Then the transfer methods is also different because the TCP reads data as a sequence, and the messages are transmitted within different segments. On the other side, the UDP messages are data packets which are sent individually, and the integrity of that packets is verified only when they arrive. The way both protocols work is also completely different because on one side TCP connection is established through a process of starting a variety of connections, and once at least one connection is being established, then the transfer of the data can start between both devices, while the UDP works in a different way and the data arrives unordered. It could be duplicated or incomplete. For that reason, TCP is way more used comparing to the UDP. So if you actually need to correct the errors of the data and to be more secure about the data you are sending, you would usually use the TCP protocol, while you use the UDP on the applications that are based on very small requests. For example, if you have just a few devices that you want them to exchange data, then you might consider using the UDP as it is way more lightweight. So this was everything, guys, I want to share with you about the TCP and UDP. I hope this lecture was interesting for you and you learned something new. Thank you very much for watching, and I will see you in the next lecture. Hello everyone, today we're actually going to dig little bit more into detail on what is IP address and how we use it to connect between different ports. So the definition for IP address is specifically used to help users to uniquely identify a device over the internet, while a port is an endpoint of communication in an operating system. For example, this is the endpoint which is waiting to connect to some other wait point on the web, and this is the way that two devices can connect over ports. So when you connect over the internet, your device is assigned a specific public IP address, while each website that you visit also has a specific public IP address as well. So both IP addresses are used for both devices to connect and exchange data. Until now, or until at least recent years, we were using the IPv4 public addresses space, which is basically a pool with all the IP addresses that are possible to be created. But recently also the IPv6 was introduced, as the IPv4 reached its limit, which was about tens of billions IP addresses possible. So as you can see, the reason why the IPv4 got retired is because the possible IP addresses of the IPv4 space were about 4 billion. At the same time, now since the internet expanded quite a lot and all of those IP addresses are taken already, for that reason now there is the IPv6, which has this amount of addresses, which I can even not pronounce how large this number is. Let's talk about the ports now. So the ports are basically numerical values that are used to identify a process that is being communicated between different IP addresses. So every port uses a single other port in order to send communication to it. So basically you need two ports and two IP addresses in order to establish communication between devices in the TCP IP network. So even if the system is running thousands and thousands of servers, in order for us to uniquely identify a service on a system, the application simply requires a port number to which to connect to. So you can see actually port numbers on the web, and by default the HTTP protocol uses the port number 80, while the HTTPS, which is the more secure protocol for connection, is using the port 443. So I pulled up for you some ports, some typical ports, so you can have a reference for them. And as we said, the HTTP is on port 80, HTTPS is on port 443, while the SSH or the secure shell is on port 22. The telnet or the remote login is usually on port 23. The SMTP is on port 25, while the DHS service is usually on port 53. So these are some typical ports that you can bear in your mind, but if you are doing custom applications to your system, you might consider to create a specific number to your port. So it is also very important to make a good difference between the public and the private IP addresses. Well, see, usually the private IP addresses range to 192.168.0.0, you might see in this, to 10.255.255.255. These are quite a lot of public IP addresses, of private IP addresses. And private means that these are IP addresses that can be stored on a local system. For example, you can run a server in your home and connect different devices with different IP addresses that you assign to them. On the other side, you have the public IP addresses, which are basically the IP addresses that you access through your internet service provider, and you can access them over the web. That's it, guys. Thank you very much for watching this video in this lecture. I hope the IP addresses and ports topic were interesting for you, and now we are a little bit more clear about what is that, because I'm sure you've seen this topic, so you've heard at least what is IP in the past, but now you know it in a little bit more detail, way better than your peers. That's it. Thank you very much for watching, and I will be waiting for you in the next video. Hello everyone, and welcome to this lecture. And this is actually the first time that we're actually going to do something on our local machine, or the way you call it, computer. So today we're going to talk about how to check the different IP addresses assigned to your computer and the different commands that you can use in Windows or Mac. So for example, a command that I usually use in order to find the IP addresses is the ifconfig command, and we'll do it shortly. So once you run this command, you're usually going to see all the devices connected into the network interfaces. Also, we're going to have a look at the interfaces, because basically every device has an interface called a loopback interface. And this interface actually doesn't connect anything outside the device, and only the specific device can communicate with it. And why we have this interface? Basically, this is because, for example, if you have a device and you want to connect to it, it already has a built-in interface which can be useful for inter-process communication with other devices. So if you don't know what is loopback interface, you might see the localhost naming, and it's almost always assigned to the IP address of 127.0.0.1. And basically this is how, for example, you can access applications in the local host or applications on your device. But let's now pull up a terminal and run some commands here. So now if I type terminal, I can see that here I'm logging into my MacBook Air, and let's try the command if config. And if I write this command, actually let me write it again, and okay, so if I write the command, you can see here different IP addresses or communications within my system. For example, let's take the first one. So the first one is named L00, and then also we have the IP address here and the different options associated with that device. So this is a good way for you to check the different devices that you have on your computer. For example, here in the EN0, you can see that the INET or the internet IP address is 192.168.107, and you can see it from here. As you can see, basically every device attached to your computer or services in use. You can see how many services are currently in use here. Hello everyone. Hello everyone. An IP address can basically be assigned to a device or network in two ways. The first way is to manually configure an IP address, which is the static way of doing it, and the second way is to do it dynamically, where the device operating system is automatically configuring an IP address, and this tool that is basically doing this is called the DHCP. So when we use the DHCP, as soon as device first connects to a network, it is automatically allocated an IP address by the DHCP service, and this IP address is taken from predefined pool. So usually the DHCP is set up by the network administrator, so you need to have that rights in order to set up this. So in order to set up the DHCP, we require our DHCP server that needs appropriate parameters in order to configure the device in the proposed network. So we need parameters such as the range of the pool, the available IP addresses, and so on. So basically, when a computer in a network wants to obtain a valid configuration, usually when we start the machine, it issues the DHCP service discover request, which generates on its side an IP address, and this is done through the UDP broadcast packet. It reaches the DHCP server, and once the negotiation is established, we're resulting in IP address assigned to the device from the pool. So it is very important to understand that in order to obtain the DHCP, we do not require any network interface configured. Also, the DHCP should be on at the same time or different time from the client or the server. So when the DHCP server receives a DHCP request for a device, the Discover service obtains the MAC address of the client and assigns an IP address to it. So the DHCP basically assigns an IP address to the client for just a certain amount of time, and the aim of the client is to do its job until this time passes or to renew the concession before the time reaches its limit. So that was everything, guys, I want to share with you about the DHCP. It is basically a service that assigns automatically IP addresses. I hope that's clear. Thank you very much for watching, and I will see you in our next video. Hello everyone, today we are going to talk about the DNS service, which is a very important one, and I'm sure that when I explain it to you, you will understand that you actually see the DNS service in use every single day. So you know that every device over the web has an IP address, but just think about it. If we use the IP address as a name of the device, which is usually the case, this name would be really ugly. We're not going to be able to remember this name, and basically for the users will not be comfortable because we understand words and letters way better than numbers. Also, it is way easier to remember a word than random numbers placed together. And here it comes the DNS service. So the DNS service is basically used to create a domain name, or to create a name that is on the top of the IP address, and basically means that we can refer to the name in order to access the IP address. So for that reason, the DNS service is one of the foundations of our network today, and it makes it more available for the normal users that don't need to remember any technical terms or numbers. So for example, if we check the IP address of google.com, you can see that it's 8.8.8, and the non-authoritative server of Google is going to be actually 172.217.4.206. But how do we check that? There is actually one command that you can use in basically every device, and this is called ns lookup. So let's go now to the terminal and let's see how this command actually works. So here I am in the terminal from my MacBook, and if you write ns lookup, so after we assess this mode, as you can see, now we can basically check everything on the web and see its IP address, which is quite useful and sometimes quite fun to do. So just think about some website, enter it here, and you immediately see its IP address. I will do a website of my desire. For example, let's do youtube.com. And if I check here, I can see the exact IP address of YouTube, which is in our case 172.217.478. Let's try another. Let's try, for example, another famous website. Let's see. Let's say games.com. Okay, so here you can see that, for example, the games.com has quite a lot of IP addresses associated with. Actually, it has 267 IP addresses associated to games.com. And let's try my website, which is called skilledarmy.com. And you can see that this is actually my IP address, which is a public one, and you can always check it from the web. Let's now try to access an IP address or a website that doesn't exist. I will just write some random letters. .com, and you can see that server can be found, and this is because this website does not exist. Okay, so here we have the server, but the actual credentials of the website does not exist because it is simply not there. So this is what the DHS is doing. For example, if you go to the browser and you write a website there, the DNS pretty much translates the name that we wrote into an IP address, so we actually access the actual numbers, the IP address that is related to this name. For example, Windows is automatically configured to use the DNS service in order to configure the internet service providers. So the DNS providers are actually pretty different. You can have different DNS providers. They could be, for example, the Open DNS, the Ultra DNS, the Google DNS as well. And for example, if you want to access the Google DNS, you can actually access the following link and see some information about it. So let's actually do it. So here, if I go on Google and go to the website that I provide you on that slide, which is called developers.google.com speed public DNS, you can actually see the information about the DNS. You can see an article, what is DNS, what are the network IP addresses, and actually this 888 is exactly the one that we found from the terminal, which is the global server. And you can actually here see some codes, information about the DNS. So I really advise you to see that page and read it, because you can see also guides and support about the public DNS services provided by Google. So that's it, guys. I think it's enough for today. Thank you very much for watching, and I hope you enjoyed the topic related to the DNS. Hello everyone, today we're going to talk about NAT and pretty much what it is and what it is used for. So NAT pretty much is a mechanism that makes the traffic from a private network to becoming just to a single valid internet address, but not to everywhere. And so in the most simple words, NAT is basically the service which effectively hides the private addresses from the internet. So yes, some of the addresses are actually private and they're used by different devices. So for example, if you want your network to use multiple IP addresses, you can locally use multiple private IP addresses and connect to the internet by only a single IP address. In that way, you are saving quite a lot of public IP addresses that you actually don't need to use, because in your private network you can pretty much choose any IP address for any device. So for example, if you are a company and you have a lot of machines in your seat, this doesn't mean that you need to have public IP addresses for all of them. Instead, you can have for all of your machines different local or private IP addresses and only one public IP addresses which will connect all these machines to internet. So in terms of that, there are two types of the NAT operations. The first one is static, where a private IP address is always translated to the same public IP address. And by doing this, your host within the network will be visible in internet. There is also a dynamic way where a router is assigned to different IP addresses. So each private IP address is mapped using only one of the IP addresses of the router that has been assigned to it. And when doing that, it is actually very important when using the NAT service to have an increased security, because we need to make it difficult for external hosts to enter the network through the public IP address. For example, you wouldn't want somebody to access your IP address and consequently your devices and to log in into your machines through internet. Now let's talk about the different IP address types, and we're going to start by IPv4. So the IPv4, the base idea behind it is to allow computers to connect to internet regardless of what device we use. So basically each device that is connected to internet gets a unique code that can be used to receive data from other connections. The IPv protocol pretty much consists of 32 bits length, which means that we have access with the IPv4 to over 4.3 billion IP addresses out there. And as we said, the IPv4 is already to its maximum capacity. So all of those IP addresses, all these numbers have already been reached. So usually the IP addresses from the IPv4 consist normally of 4 groups of 8 bits. 8 bits means that there are 256 possible numbers for each position. For each of those 4 positions, you have 256 possible numbers. And this is how actually we're calculating how many IPv4 IP addresses are. You just need to multiply 256 4 times. So 256 multiplied by 256 multiplied by 256 multiplied by 256, and you will get some number around 4.3 billion. So according to the rules for obtaining the IPv4, there are few classes that are ranging different IP addresses. Class A, Class B, Class C, Class D, which is the multicast, and also Class E, which is the experimental class. So the multicast and the experimental IP addresses usually cannot be used as a source of addresses, so we cannot usually use these addresses because they are already in use. We normally have the IP address 0.0.0.0 as an identifier of the IPv4 and 127.0.0.0 as identifier of the physical loopbacks over the network. And also we have the 255.0.0.0, which basically identifies the broadcast addresses, so we can also not use these ones. Now, what is IPv6 and what is the use for it and what is the need for it? Well, basically the IPv6 consists of 128 bits, which is way more numbers comparing to IPv4, and we created this space of IP addresses simply because we run out of IP addresses over the web. So we wanted to ensure that we have that space, and the IPv6 addresses are no way near to getting expired because there are so many of them that we would never be able to reach. They basically consist of 8 groups of 16 bits. And as you can see an example of IPv6 address, you can see that 16 bits means that these 8 groups can include not only numbers but also letters, which increase further the number of possible IP addresses. For example, if we go now to the terminal, we can actually check that. Let's exit here, and then I will write if config, and if we take a look here, you can see that in the Ethernet, in the iNet or the internet, we can see an example of the IPv6 address, and you can see in iNet 6, which is saying to us that is IPv6 format of address, and you can see all the letters. So this is actually an IP address. And for example, if the mode of the IP address is IPv4, you can actually see that here we get it in that format. So you can make the difference between the IPv6, which is this type of IP address, and IPv4, which is the other type of IP address. And if you want to take a look at your computer, you can definitely do it with the ifconfig command, which will basically show you all the IP addresses on all the devices connected to your computer. That's it, guys. Thank you very much for watching that video. I hope now you're pretty clear about how your computer connects to internet and how our devices basically connected to your computer. That's it. Thank you very much for watching, and I will see you in the next video. Hello everyone, today we are going to talk about libraries that you can install in Python in order for you to be able to access different packages and use it throughout this course. So here I pulled up a terminal, and usually we're installing packages in Python with the pipe keyword. So today we're going to install some packages. There are a few tools that you can use in order to install packages. So the first one that we're going to talk about is the CADA tool, which is actually a tool developed by the Anaconda distribution. And if you use Python before, you will probably know that Anaconda is one of the most famous Python user interfaces that you can use out there. So they also created their own way. Yeah, so I did a spelling mistake, it's actually with O. So pipe install conda. And as you can see now, this package is installing, and you can use the conda package in order to install different packages in Python related to the conda toolkits. So now you can see that the package is actually successfully installed. And for example, if you want to use it in order to install packages, you can simply write. For example, if I do conda install requests, it asks me now to install the mini conda installer from that place. And let's actually go to their website, and you can see that, for example, it detected that I am a Mac user, so I can actually download it and enable the installation of those two toolkits. So if you would like to enable this on your computer, simply go to this website, and then you can install actually what you need. So you need to go to anaconda.com products individual, and then you will be able to install the additional package needed in order for you to use CADA to install packages. But since I don't use CADA to install packages, I will not go to this website because I don't need it currently. Now, the next way for you to install packages in Python that we're going to cover today is by the virtual env. So in order to install this, you can just do pipe install virtual env. Okay, and you can see that the installation now begins, and it says that the request is already satisfied, which means that I already have installed this package in my computer. And the final tool that I want to show you that is good that you have it on your computer, it's actually an official Python installer, which is called pipe env. So if I do pipe install pipe env, you see that I also get that the requirement is already satisfied because it's automatically installed once you install Python in your computer. So you should probably get the same message, but even if you start getting the installation package, this is also fine because you will simply get it installed in your computer. You can actually find more information about the pipe-env on this website, realpython.com, pipe-env-guide, and here you can find the different commands that you can use in order to put in the best practice the pipe-env toolkit. So these were the alternatives, guys, to pipe that I want to share with you. In this course, mainly we're going to use pipe to install packages, but we might face the need sometimes to use also other tools in order to install packages in our computer. That said, thank you very much for watching this video for today, and I will see you in the next one where we're going to talk about sockets. Thanks for watching. Hello everyone and welcome back to this video, and today we're going to talk about sockets and what actually sockets are when we're talking about network connection. So basically socket in Python, so socket is a Python term that is basically used in there as a standard interface of the transport layer of the TCP or the UDP layers. So this is basically a way to transport data. So when you run a socket in Python, it basically interacts with the TCP and the UDP transport layer types, and also it is looking up for the DNS, which is the host name of the IP address. A socket is defined basically by the IP address of the machine, also on the port of which it listens and the protocol it uses. For example, if you have a socket, it will be connected to the IP address of certain machine, it will listen for certain port to get access, and also it will use certain protocol, whether TCP or UDP. So sockets are basically classified into stream sockets and we can either have stream sockets or datagram sockets depending on whether the service is TCP or UDP. So if the service, for example, is TCP, then we would have stream socket, and if the service is UDP, we will have a diagram socket. At the same time, they also classify by family. For example, if you want to talk about the Unix sockets, which is specific to Unix, then you would have the sockets.af Unix. So this is a family of sockets. Then if you want to talk for sockets depending on the networks that they are based on, then you would say sockets.afnet file. And finally, if you want to define sockets, the family of sockets depending on the type of internet connection, then for example you would have INET6 or INET4 sockets. So for example, guys, these three sockets here, they are based on family. Okay, so these are all the family sockets, and at the same time you can have the sockets based on socket type. For example, here I write type. So based on socket type, there will be sock stream and sock DG RAM. So sock stream, this is related to the TCP protocol, while the socket DG RAM is related to the UDP protocol. This is important to understand. So after we know this, let's go now to the terminal and let's do some operations with sockets. So first of all, you will need to install the socket package in your computer. You can simply do pipe install sockets. Okay, I misspelled this, it's with E, sockets. And you can see that requirement already satisfied. I already have it installed in my computer, but if you don't have it, you will see this. Let me uninstall it. Okay, uninstall sockets, yes, and let me install it back again. So you will see that if you don't have it installed, it installs sockets like this. So it collects all the sockets and then starts the installation, and the installation is complete. Actually, this is one of the fastest installing packages in your computer, so it should be quite straightforward. So for example, if I want to access the sockets from the terminal, you can simply write Python, and then as you can see, you're getting to the Python terminal, and now you can write different Python commands. For example, if I write a print statement, for example, if I write print 1, then it returns 1, or print hello. So if I print hello, the system will return me hello. And this means that we're accessing now the Python environment, and here you can simply import sockets, or socket actually. And for example, if you would like to create a socket object, you can do the following. You can write client socket equals socket dot socket, and then in the brackets you can write socket dot af underscore inet comma socket dot sock underscore stream. Okay, and if you see the presentation, you can see that when we create socket, first of all we define the family of the socket, which in that case is af inet, and also we define the type of the socket, which is the STREAM, which is the TCP protocol. Okay, so if I hit OK, you see we're not getting any errors, which means that our socket is created. And for example, if you want now to connect the socket to the server, we can usually do that with the connect command. We can do client underscore socket, so this is basically the name of our socket, dot connect, okay, dot let's open bracket, and let's write the name of the website that we want to connect to in the web. So I write youtube.com comma 80. So here we're connecting to youtube.com on the socket 80, so we connect to the web server. So here is an error, guys. I actually put 80 into the parentheses, so let's change that, and you can see that now our code is accepted, and here it says the AFNet should be a tuple, and now it is a tuple, which is fine. So here now we created basically a connection to the web server of YouTube on port 80. Also, let's try other commands, for example the bind command. So let's create another socket. So I write here server socket equals socket dot socket, and here I write socket dot af inet comma socket dot sock stream. So we created the inet socket, which is with the TCP protocol. Let's run this. Okay, and now we're going to bind the socket, and now we can make this, and now let's make server socket dot listen 10, which means that our socket will listen for maximum 10 connections. Okay, that's it. So this is how you deal with sockets, guys. I hope this lecture was quite informative for you, and that's it. Thank you very much for watching, and I will see you in the next video. Hello everyone, today we're going to talk about the RFC, and if you wonder where I am in the public RFC directory. So RFC means request for comments, and this is basically series of publication of the Internet Engineering Working Group that describes many operations in Internet and other computer networks, such as protocol, procedures, and so on. So to develop the RFC, basically engineers, software engineers around the world are making a collaboration so they can build a community to constantly develop and update this information. So RFC pretty much covers a wide range of standards, and we can start by saying that it covers the TCP and the IP protocols, and they're all available on this website that you can see in front of you, which is itf.org/RFC. So as you can see that each RFC or each document has a number, and for example, if we search for the number of the IPv4, it is 791. So if I search for 791, you can see that we have many documents that are describing the IPv4 protocol, and let's open some of them. So you can see that here we have a pretty large document, and all of those describes the protocol specification, and this is actually one of the first documents that describes the protocol specification from 1981. So here you can pretty much find all the information related to sockets that you actually need. For example, the HTTP protocol, for your reference, can be found on 2616. So if I search for it, this is the HTTP protocol, and you can basically find everything about it here. Okay, it's a very huge specification, over, I think it's about 200 pages. But like, if you're interested to dig into more detail, for example, about the HTTP, this is the right place to go. If you want to find something specific but you don't know the number, you can go to the RFC search, and here you can search by the RFC number or title or a keyword into that protocol. For example, if I write here HTTPS and I search, I will get all the documents that are related to the HTTPS protocol, and I can easily find them. For example, I can see that the HTTPS is 4848, RFC 4848. So it is very important to know this source, because you can really use it for your reference when you are working. And I noticed that not many engineers are knowing about this database. So for example, here you can also choose how you want to see the document, in the SCI code, in PDF, or in the HTML. Like if I press in HTML, you immediately see this document in the browser. So it's quite convenient, and I really advise you, if you have any questions about the acronyms or the protocols that we're using here, please go here and reference to the documents here, because this is really what all the protocols are based on. For example, if I write TCP, you're gonna see the TCP protocol, and so on. So in order to access these documents, we can actually build a Python script in order to access them from the web. And for example, when we're using certain service or certain protocol in internet, to immediately download and transfer the specification for that protocol, so we can take a look at it without the need to go to this website. And actually, I'm going to explain you how exactly you can take documents from the RFC database using Python. Hello everyone. Today I'm in a website called Wireshark, and Wireshark is a program that will allow you to follow your traffic that is going through your computer. It is actually quite a useful program, and you can see all the connections that you have with internet, and trust me, sometimes you're even going to be surprised on how many connections you will have on your computer with external servers, HTTP, HTTPS clients, TCP clients, and so on. So let's go here and hit download in order for us to install Wireshark for our computer. Since I'm using macOS, of course I'm gonna install Wireshark for macOS, but if you use any other version, for example Windows, you can install Wireshark for Windows. So just hit the download file and Wireshark will start installing to your computer. Once Wireshark is installed, or actually downloaded, it's time now to install it. So just drag and drop it to applications folder, or if you have Windows, simply double click on it, so it starts copying to your applications folder and it actually starts installing inside your PC. Then double click on it here and select open. So once this is done, now the Wireshark will start opening, and you can see that it actually opens quite fast. So what you see here is basically the gameplay of Wireshark, and you can see that here we already have some heartbeat, and what it basically does, it checks the different services in your computer and checks where information is being exchanged. So if I select here Wi-Fi, which means your connection with internet, then I will see all of your connections with internet. Let's select it. And now you can see that we're connecting to different servers with different protocols. You can see here we have the TCP protocol, we have the TLS protocol, the UDP, and so on. And once you select each of those packages, you can see the specific information about it. You can also search different protocols here in the search, but this I will show you later on once we start working with Wireshark. And what it is basically shows is with what type of locations your computer exchange information. So you can see with how many locations in internet your computer is exchanging information. Even in some case you're sending information to that services, so they can have some bits of your personal data, which of course when you look at how many locations you are sending your personal information, it might be freaking out some people. But anyways guys, this is how you can use Wireshark. As I promised you, it is really simple to check the different connections. So here you can see the connections with internet. Of course, Wireshark is widely used also to check local locations with different machines in your network. But since now we're talking about connecting with web services, for that reason I'm sharing with you all the web services that this computer has, and we'll continue exploring that. That's it guys, thank you very much for watching that installation video, and I will see you in our next videos. Thanks for watching. Hello everyone, today we're going to dig a little bit more into the Wireshark tool and talk about the possibilities for assessing the traffic that you have when using the tool. Let's actually go to the EN0 and see everything we get there. So you can see that here we have a few TCP protocols and they continue updating, and you can see that there are different colors for some of them. So this is the network traffic, and the network traffic basically is the amount of packets that are moving across our network. So usually we can say that the traffic volume is equal to the traffic intensity rate multiplied by the time. So if we want to estimate the traffic volume for, let's say, 1 hour, this will be the traffic intensity rate multiplied by 1 hour, or the packet that we receive per hour. So you can see here that for every packet there are several pieces of information. So here we see the time, or the time at which the packets are captured. Then we see the source, or from where the packet originates. Then we see the destination, which defines the place that the packet reaches its final location. Then the protocol, or the type of IP that the packet followed during the journey from the source to the destination, and you can see that there are many different protocols here. And then we have the information about the packet, which is some additional notes for you to read if you want to assess it. Now, information or samples for capturing files you can actually assess on wiki.wireshark.org sample captures, and you can read through these bullets here. If you want to dig a little bit more into the Wireshark tool, I advise you to investigate some of the protocols, especially the most famous one. For example, if I search here for HTTP and I select this protocol, you can actually find different files that contain HTTP requests and response for you to test the HTTP traffic on your device. Now let's talk about the colors in the Wireshark tool, because now you can see here different colors that you might not be clear exactly what they mean, you know. So let's look at them and let's try to explain them. So when you're capturing packets, Wireshark is usually using colors to identify different types of traffic that occur. So if I double click here, you can see all the information about the specific packet available in front of you. And also, if I go to view and then I go to colors or covering rules, you can see all the covering rules that are available here. And you can see that, for example, if we are getting the bad TCP protocol, it's gonna be displayed like this, with this bluish green color with the red. Then the state change might be displayed in orange, which is usually a warning color. And you can see also the rest of the covers. So if we get into any of those states, we're going to get the specific cover that refers to that state. You can obviously tick and untick these boxes if you would like to see this warning or this display over the certain connections that are in certain state. So for example, if I remove the tick here from the bad TCP, it will actually be removed from our screens and you will not be able to see if there is a bad TCP. So also, as you can see guys here, as my system keep updating and new connections are received, you can see that the list of connections is actually going quite big. Like, we have plenty of connections, and trust me, their number will increase over time. For that reason, it is a very good idea to use filters here in order to find the desired connection that you need in order for you to do your job and to find the exact connection that you require for your tasks. So with the search, it allows you to see the data collection only that fit to your search criteria. Actually, the search criteria is supported by the library called, actually I'll write it here, it's called libpcap, and this is usually the library in the background that works with your search. And for that reason, for example, if I write TC, you can see the different parameters from this library related to the TCP protocol. You can see them here. And for example, if we search for a protocol, for example, the DNS protocol, if I search for it, you can see that it filters only the traffic that is coming from the DNS. You can also click on different tabs, such as the Analyze tab, and you can see here we have the display filters, display macros, so we can also use macros here. We can apply different filters and so on. We have plenty of options here, but if we select the display filters, you can actually see the display filters that you can apply when you are capturing packets with Wireshark. So these are usually the main filters that you can use pretty much. For example, if you want the HTTP traffic, obviously you're going to use the HTTP filter, and here you can simply see the name and then you can see the filter here. So let's check the IPs that are with the expression IPv6. So here if I write IPv6, you can see all the traffic that is coming from the IPv6 and so on. So use the filters and investigate them. You can also do this from the Wireshark website. So they're quite useful, especially if you want to find data among many different traffic collection messages. So it is good to note that you can actually filter your connections or packets by different criteria. For example, you can use the HTTP filter by typing HTTP dot content type, and you can actually search for the type of different content of the website, or you can search for the full address of that website. For example, if you write HTTP dot location, so you can see that here it is in green, so you can pretty much filter here by location. So that was everything, guys, that we wanted to cover about this tool. Please use it in your favor in order to analyze the different connections. So that was everything for this lecture, and in the next one we are going to talk about PyShark. Thanks for watching. Hello everyone, did you know that PyShark library is used to analyze the network traffic in Python? So since we already use Wireshark, we decode in each packet that you can see in front of your screens. So this packet is actually available as variable. And what Python does the best? It works the best with variables. So let's go now to the terminal, and I will make it a little bit bigger so you can see. So let's now install the PyShark inside our devices. So I will do here Python, actually I will do pipe install PyShark, okay, install PyShark. Let's hit enter here, and now you can see that our computer started downloading PyShark, and it's actually successfully installed in our computer right now. So guys, since we already installed PyShark, let's now get some additional information about the PyShark. So you can access PyShark with the following command: First, go in Python mode from your terminal. So I will do Python, and now you can see these arrows, which means that everything that you type will be understood as a Python code. So if I write import PyShark, so after you installed the package, you obviously need to also import it in your Python code that you use. So I'll import PyShark. Okay, it's imported now, and let's do help PyShark dot capture dot file capture. Okay, so when I run this, you can see all the information necessary for you in order to access PyShark. So this is the actual class we're using, the capture class. So you can see how from just typing a command in the command line, we can already see files stored in the cap file. So this is all the information you need, guys, for PyShark. You can also see some parameters here: the default batch size, the log level, the encryption standards, which is the WEP and the WPA, and so on. So that was everything for today, guys, and what I want to explain you about PyShark and how to install it. That's it. Thank you very much for watching, and I will see you in the next video. Hi everyone, and welcome back to the course. Today we're going to talk in this section about programming in the web using the HTTP protocol. You learn how to make requests on the web and retrieve web resources. You will be trying here plenty of example requests. You will be using the URL library, and you will be working with different forms and cookies over the web. So in this section, you are basically going to gain a strong understanding about the URL library package. You understand how to use the request package as well. You learn how to handle forms using the URL library and the requests with Python 3.7, and actually we're going to use even the newest Python version, which is going to be 3.9. You learn how to handle cookies with the same packages. And finally, we're going to talk about the HTTP and the HTTPS authentication methods. So let's go to our terminal and let's get started. Now let's pull up a terminal, and here's our terminal. Let me actually make it a little bit bigger so you can see better. So here's our terminal, guys, and we're actually going to run some files in order for us to start building requests and cookies. So as I said, the first resource that we are actually going to use is the URL library. And basically the URL library allows you to access any resource that is published on the network, such as files, pictures, directories, and so on. It's a very powerful tool, and it uses the protocol HTTP in order to access these files over the web. Now, how you can import it? Let's go to Python mode. So here we're in Python mode, and you can simply import URL library. Okay, and you can see that we don't get error. So this is the way you can import it. And also, if you get error here, this means that the library is probably not installed in your computer. So you can write then pipe install URL library, and if it is not installed, it will immediately install in your computer. But as here this is a library that is pre-installed, now you can see that I'm getting an error message that I don't need to install it. So let's go to Python mode again. So when we're talking about the URL library, there are basically 4 functions that are covering this library. The first one is the request, which simply opens and reads a URL or some address over the web. Then we have the error, which contains the errors generated when you're making the request. Then we have the parse tool, or called parse, which basically converts the URL into the readable information for you. And finally we have the reboot parse, which basically converts the reboot txt files. And as a matter of fact, if you go to this website docs.python.org, and if you search for the URL library.request, you can find all the documentation for the URL library.request and actually find all the functions related to it. So once we complete this section, if you want to use some additional functions, this is a great place to go and see what each function is doing and simply use it for your needs. This here is the URL of the library, so you can simply type it in your browser and you'll gain access to it. For example, if I search here for URL open, we're getting here the URL open function, and you can read the documentation for it. So here, this function URL open is simply creating a file similar to a text file that is extracted from a URL. So what the system does when you use this command here, it basically converts or reads the URL and converts it to a file. And this object has many different methods such as read, read line, read lines, close, and so on. Once you create the file, you can basically manipulate it in a way you like. For example, let's try it here. So now we're in a Python mode, and let me show you how we go there. So let's write Python, and once we're typing Python code, you can simply write from URL library dot request, so request import URL open. Okay, so now we imported the URL open option from the URL library.request, and then if I write a response, so this is going to be a variable, so response equal to URL open. Okay, and let's type some example address on the web that we would like to explore. For example, let's add one of the most famous websites, youtube.com. So if I do http://www.youtube.com, okay, and if I run that, okay, we're getting an error here. Let's see where it is. Yes, here I misspelled the URL open, so let me fix that. And now you can see that we're not getting an error, but we also don't display anything because we need to call the variable that we just created, which is called response. So if I write response here, you can see that we already got the http.client http response, and we have the address of the object. So this means that we already pass the data from YouTube to that object. And if I write, for example, now response dot read line, you can see that we can perfectly read the data that we received from YouTube. So by read line, we usually receive an HTML file once we get the youtube.com, and this HTML file goes to the response object. So here, by writing read line, we simply get the header of this HTML file. Okay, I mean, the way that this file is written here is not very understandable because it's just written on the same line, but if you put it in the correct HTML converter, you see it very well with the different indentation levels. But we are not going to do this right now because we have way more important jobs to do. So if I write now print and then URL library dot request dot URL open URL open, and after that if I write again YouTube, actually http youtube.com, and then timeout equals 13, let's run it and see if we're gonna get any error. So here we get error with the URL defined, so I will import it. So import URL library, okay, and then I will run the command once again. So you can see that here we simply return the HTTP response interface, and actually this response gives us the data from the request that we made from the resource on the web, in that case youtube.com. Also, we can use a JSON format in order to do that. For example, if I import JSON, okay, and I do response equals URL library dot request dot URL open, and then URL comma timeout equals 30. Actually, let's put instead of URL HTTP then youtube.com, so we have exact URL here. Okay, and after that I can simply do JSON underscore response equals JSON dot loads response dot read. Okay, so this is another way to do it, and we actually got an error here, so let's try to fix it. Everything seems correct. Maybe just the website that we were using didn't have the right data in order to use the JSON on it. So let's skip this step for now, because I want to show something way more interesting. And this is specifically the status codes. So usually the HTTP provides us with a way to see the status of the response of the request we are making. For example, if I see a status of 100, this would mean that the response is informational. Okay. For example, if you see code of 200, this means success, which means that the command is executed correctly. For example, if we see code 300, this means redirection. If we see code 400, this means client error, and if we see 500, this usually means server error. Okay, so these are all the codes that we could see, and let's try to do one operation, or actually check what is the code of our response file. So if I do Python and I do resource dot status. Okay, let's redefine the resource once again. So let me import once again the URL library, and I will also import the URL open, so I can recreate what we already had. So let's run this. Actually, here I write YouTube. Let's run it, and now we can simply do response dot status, and we will get that the status is 200, which means that we successfully collected the data from our data source, which is quite good. And this is the way that you can check if you get the right data, because code 200, as you remember, means that we have a success in collecting the data. This was the last thing I want to share with you for today, guys, but we have more yet to cover in this section. So thank you very much for watching that video, and I will see you in the next one, where we're going to cover how to handle exception using URL libraries in the network programming. Thanks for watching. Hello everyone, today we are going to learn very interesting things. The first thing, and actually the main topic of this video, is how to handle exceptions. And also I will teach you how to create a custom Python file and then run it from the terminal, so you can write a huge amount of code which later you can simply run. So as you can see, I already created on my computer a folder called section 2, which is actually the section and how I structure the sections in this course. So in that folder, which is specifically for that section, I will actually create another folder called resources. Okay, so let's enter this folder and let's create a text file. So on Mac I usually use text editor, but feel free to use any text editor. I think on Windows is Notepad to create a text file. So here I will create a new document and I will save it as exceptions.py. And then the only thing I will need to do here is just write .py after it and select use py. So if you're on Mac, you will need to do the same thing, but if you use other devices, you will not need to do that. So when you open the file in your preferred text editor, actually here we're going to use PyCharm, so I'll run it. I'll write PyCharm. So here, once you enter PyCharm, you can simply select open and go to the file that you actually want to open. So here I access the file exceptions.py and select open, so now you can edit it with PyCharm or actually any editor that you would like to use. So let's write here import url library dot error, and then I'll write from url library dot request, and from here I will import the URL open, so we can actually open a URL. And here's how we do the exceptions. So first of all, let me tell you why we actually need to do exceptions. Basically, in every programming language, and Python is no different, we need to do exceptions in order to be sure that the program runs correctly, even if we have some errors. So it is always better to create an exception for an expected error in order to show the user the exact notification and the exact information for fixing that error. So here's what we will do. First I write try, okay, and try means that we're going to try some command, so we will try URL open and then the name of the website, and here I prepared one website that has an error message inside it, so I will do HTTP and the website is called www.ietf.org rfc0.txt. Okay, so this is the web page that we're going to access, and in case anything gets wrong and we're not able to open it, let's write except URL library dot error dot http error as e. Okay, so if we get this error here that you can see from the error library, in the code below, this error is going to be expressed with the letter E. So I can write print and in parentheses exception comma E, then print status /e dot code. Okay, then we'll print the reason for the error, so reason, comma e dot reason, and finally we will print the last line, which will be URL. Okay, and I write e dot URL. Okay, so here if we get this type of error, HTTP error, then we're going to show plenty of information for it instead of simply displaying the error to the user. Let's save that, so I will do Ctrl S, And let's actually run the code. So I'll simply go to the terminal and I'll go to the folder, so cd, so I'll go to section 2, AOS, and here we have the resources file, the resources folder, and you can see the exception py is there. So you can simply do Python and then write exception.py. So once I run the file, you can see that we've got the exception HTTP error. Okay, and this means that the page is not found. Okay, so this is what we would get if we don't add the additional lines with the exception. But since we added the exception, we can see the status is 404 with this code. The reason is that it is not found. The URL, because here you can see we don't have the URL, the URL is this one, the ietf.org. So you can see all this information, and you can actually add more information if you desire. So you can see these 4 lines of code when you get an error. And let's say if we do not write exception, for example, if I don't use this code but I simply write URL open and then write the address, actually let me copy it. So if I just copy this here, I basically get in some mode and I see nothing about the fact that we actually got any error related to what we just did. But since we get the exception and we have this exception, if any issue happens, you can always see the error message and what are the details regarding that message. So this is quite useful. So this is everything I want to share with you guys about exceptions. I hope you enjoyed this video and you actually learn how to run Python codes within your terminal machine, which is quite well because we're going to use this actually quite a lot. That's it. Thank you very much for watching, guys, and tomorrow we will continue with the HTTP headers. Thanks for watching. Hello everyone, welcome back to the course. Today we are going to talk about HTTP headers. And what HTTP headers are, if you remember, we actually did some coding regarding them. HTTP headers are basically the information that an HTTP file contains, which is located on the top of the HTTP message. And for example, you can see in front of you how actually the HTTP header looks like. So you have here what is being accepted, what is the acceptance encoding, what is the acceptance language, what is the connection, what is the host, and also the browser that we entered from. Quite simple. So usually the HTTP request contains 2 main parts. These are the header and the body. So usually in the header you can see information about the specific data that is inside the HTTP protocol, and it will basically tell you how you can interpret that data. For example, here if you have the accept language to US English, we know that the rest of the code it's probably going to be in the US English, or the whole website actually. For example, quite important part of the header is the host header, because many of the websites out there, or the web servers actually out there, allows you to host more than one website at the same time using the same IP address. So for example, if we're using the DNS protocol, you can have various website domains that are hosted from the same IP address. So let's write one code that is actually going to show this. So let's write a script that will actually obtain a header of a website using the response object and response libraries that we already know. So here in this project that you already created here by opening the exception.py, so here if I press new file and I select Python file, let's name it headers. Okay, so now we're updating the headers file, and this file, as you can see, once we created it, it is automatically created inside our resource folder. So now we have here the headers.py, and we can actually write code inside it. So let's write a hashtag and then user /bin/env python3. Okay, so we assess the environment of files, and then let's write import url library dot request, and then let's write url is going to be the name of what we're creating, input, and then enter the URL semicolon, and here we're going to ask the user to actually enter the URL. Now let's write HTTP response equals to URL library dot request dot URL open, and then let's write here your URL. Okay, so we're gonna take the URL that the user has inputted with the input command, and then we're going to do an open of this IP address, or of this URL actually. So let's write then HTTP, actually I write if HTTP underscore response, actually I misspelled this, okay, HTTP underscore response dot code is equal to 200, so this means that our request has been accepted. Then we would like to print HTTP response dot headers, okay, and then for key comma value in HTTP response dot get headers. Okay, here I misspelled for. Let's see. Okay, this error is removed now. So for key and value in get headers of the HTTP response, let's print key and value. Okay, so we're gonna print both of those elements inside our get headers. So let's actually save that, and I saved it, and let's go to our terminal. I hope you understand what's happening in here. We're simply going to output the header and print some additional information about it. But let's run the code and see what happens. So if I do ls here, you can see that now we have two files, and I will do python exception.py. Let's run the code. Oops, sorry, we had to run actually the headers. So let's run headers.py, and it asks you to write URL. So I write http youtube.com, and let's see what happens here. So as you can see, guys, the code went through youtube.com. Where did I write it? Here. And then we started getting all the content of the youtube.com. So we can see the date, we can see some security guidelines, you can see the server name ESF, this is the server of YouTube. We can see the set cookies mechanism, and so on. We even get information for multiple servers. So this is how basically the header looks like, and this is how you are basically getting the header, the key, and the value of that header as well. So that's it, guys. Thank you very much for watching. I hope the HTTP headers are clear for you now, and how you can basically extract this information from internet. Please bear with me in the next video where we're going to cover the user agents. Thanks for watching. Hello everyone. Every file that communicates using the HTTP protocol can be referred as user agent. So the user agent should usually use user agent header to identify themselves when you or me, let's say, will make a request to get their information. So let's have a look about how an example user agent would look like. To do that, let's go in Python mode. So let's write Python, and I'll write from URL library dot request import request, and then from URL library dot request import URL open, and after that let's write requeue equals request, and let's write an example website. Again, I will write for simplicity http youtube.com. So here I misspelled request, so you can fix that by typing here, and now you see we don't have any error. And now if I write URL open requeue, so since here we call the website as a request, so if I open this, you can actually see the URL request, and this is something you've already seen. But let's now check the user agent. So to do that, you can simply do requeue dot get header, and then let's write user under slash agent. Okay, let's hit enter here, and you can see that our user agent is Python URL library 3.9. Okay, so basically this is the agent, or this is the tool that we used in order to access this website. Okay, so the tool that we used is Python. For example, if you would like to access some website from the browser, then your user agent will be, let's say, Mozilla or Opera or Safari or Chrome and so on. So this is what I wanted to show you guys in this lecture. I hope it was useful for you, because sometimes you really want to understand what tools you are using in order to assess certain agent, especially in automated systems. So have this in mind, and you can always use the user agent in order to get the tool with which you assessed a certain URL. Thank you very much for watching, and I will see you in the next video. Customizing requests with URL library. Hello everyone. So far we learned how to obtain headers of certain files, but why we actually need them and what is their use. Well, usually it is a very good practice to add headers to the request even before sending it. So if I create a new slide here, to do this, we basically need to follow 3 steps. And the first step will be create request object, and this is usually done by the request class, and we actually already use that class. Then we would like to add headers to the request object that we created from the request class. Okay, and after we create the request object, which is a physical thing, so from the blueprint of objects of requests, you created object called request. So after you created it, you would like to open it, so we would use the open feature in Python to open the request object. And actually this feature you're also familiar with, and this is the URL open feature. Okay, you can use this from the Python packages. So let me show you how this is done. If I go to the terminal and now we're in Python mode, let's first import some library. So write from URL library dot request import request comma URL open, so you can import both of them at the same time, and then following step 2 here, following step 1, after we imported it, we need to create an object from the request class. That's very simple. Let's write request equals request. So this is, now we're creating an object from the request class, and the object is going to be referred to the http youtube.com. okay, that's done. And then if you would like to add a header, so for example, now the request is created, but it's a good idea, as we said, to add a header to the request, and this is the second step. And how do we add header? Very simple. Let's write request dot add header, and here you can basically type the header that you would like to add. For example, I can say accept language. Actually, let me do a dash here. Accept language. Okay. Comma NL, or let's do EN for English. Okay, let's hit enter here, and for example, let's now open our request and see the header of the request. So obviously, when you want to check out a request, you sometimes don't want to see all the information because there is plenty there, but maybe you would just like to see some information that will tell you what the data there is all about. So you can simply do response equals URL open, and then I will do request, I will write in the brackets, and then we can actually read the lines from that request that we already made. So here we already opened the request, which is the third step with the URL open, and now let's check actually the result of our work. So if I do response dot read lines, and then I would like to check, let's say, the fifth line, so fifth, okay, and you can see how messy, for example, the fifth line it is. I mean, I see it messy here, but if you would have a software to open this line in a structured way, it won't look that messy. So if I would like to check, let's say, the header items, I can do req dot add, req dot header items, okay, and if I hit enter, you can see that the host here is the youtube.com, the user agent is Python 3.9, and then we also get the addition to the header that we added, accept language en. Okay, so this is how you can actually add information to the header, and it's quite important, especially if you want to add something for the readers or for the people that are checking your request. So as I said, you can simply use these three steps: creating the request from the request class, then adding the header, then sending the request by the URL command, and finally you can simply check the header by this command, and you can see that the additional header that you added is already there. So let's see how this would work if we add it in a file. So let's create a new Python file called add header. Okay, so actually let me get a bit closer and open this tab a little bit so you can see actually better. Okay, I think that's better. So let's create the file now. Let's do a hashtag user bin env. So this says where Python is, Python 3. Okay, and then we can do from URL library dot request import request, and then we can do user agent. Okay, this is a custom variable, and we can set the user agent as Mozilla 5.0, this is the version, then Windows NT 5.1 semicolon RV, and then we can do 20.0, that's it. Then let's write GECKO 20.10.0.101, and this is simply an example user agent, and then Firefox /20. Okay, and then the URL, so I write URL will be equal to http youtube.com, our favorite browser, and after that I write a function. So let's write def add header, and this will be our main function. Let me add underscore here, that's it. Okay, so let's create a variable. This will be called headers equals accept language, and then semicolon n1 comma, and then I will do user agent, and then semicolon user agent that we already created. Okay, so actually the user agent is going to be this one, the predefined variable that we already created up here. Let's go to the next line. So I will do request equals to request, and then URL. Okay, so this is the URL that we predefined, youtube.com. Actually here I missed the slashes, but that's fine now. So let's do after that headers equals headers. Okay, and then let's write print, and in the print statement I will write request headers. Okay, and then for key value in request dot header items. Okay, so for this I will print, and here we're gonna print %s, then %s, then %key value. Let me write comma here, key value, and that's it. Actually, let me remove this, and I will need to put it exactly here. And that's it. So first will be the key and then the value. Okay, and now let's run the function by simply typing if name equals main. Okay, let me add the underscores. So if name equals main, then I will do add header. Okay, then we will run the function. This is how you basically run the functions in Python. So let's save this file now and let's try to run it from the terminal. So I'll exit the Python mode and let's write whois here to see what we've got. So let's write Python add header, and you can see that after we pressed add header, we automatically get the accept language as N1 as we set it up. Okay, the user agent, we get the user agent that we set it up on the top. And so this was the information that we requested in here in the header section. So our test is completely successful and the file ran properly. So this is how, guys, you can pretty much design and add headers to your URLs. I hope this video was useful and I will see you in the next one. Hello everyone. Today we are going to talk about content types, and let's first explain you what is content types, and then we are going to do some tests so you can see visually an experiment with this type of topic. So as HTTP can transport basically any type of data, the server usually uses the content type in order to add in the header an information about basically what is the type of the file that we're obtaining from internet. So having the type of data basically helps us to know how to deal with it, and this is because you're actually not going to be dealing with picture in the same way, for example, how you would deal with a text file, right? So for that reason, it is very important to have the content type and to be able to know how to obtain it. And let's actually open the terminal and I will show you some example of that. Now, if I write Python, and so we enter the Python terminal, we can simply write response equals to URL open, and then I'll write HTTPS or HTTP youtube.com. Let me change here the parentheses to just a single one, and let's actually import the URL. Let's do from URL library import URL open, actually from URL library dot request, that's it. And also let's import URL library, that's it. So once we have both of those libraries, let's repeat the response action with the youtube.com, and you can see that now the request is accepted. So let's do response dot get header, and here we would like to do the content dash type. Okay, so if I do it, you can see that the content type is text HTML, right? So here I can see basically what is the content type of the page that I access in youtube.com. So we can see that it's HTML. Obviously you can access plenty of files. So since you already know how to do that, let's talk a little bit about links. Or you know that every website has many pages which refer to links. And sometimes maybe you would like to see all those links, right? Well, in that case, we can use the URL library in order to see or extract some of those links. And obviously, this is part of the Python packages, so you can get more information at this web page here the HTML parser. So if you're interested, simply go to this page docs.python.org and HTML parser, okay? Because this is what we're going to use in order to extract links. And here you will see many functions, even functions that are actually not covered in these videos if you feel the need to use them. But now let's go to the Python directory here and let's create another file. So the file will be called extract links. So Python file extract and then underscore links. Okay, so let's create a new Python file called extract links. I will save it and let's try it now. So I write, actually let's get a bit closer so you can see. Then I will write user /bin/env to access the Python file, then Python 3, and then from HTML dot parser. As I told you, here we're using the parser command, and I will do HTML parser class. That's it, and then I will import obviously URL library dot request. And now let's create a class. So the class will be called my parser, and here I will pass HTML parser. Okay, so from the class HTML parser we're basically going to create the class PyParser. Okay, then let's write def handle underscore starting. Okay, and here you need to define a few attributes. Self, obviously for the current item passed to the class. Actually, let me do semicolon here. So self to the current item passed to the class, then tag, and then attrs for attributes. Then let's do if tag equals a. So in that case, what we would like to do is to do a statement for a in attributes if a0 is equal to href, then let's do link equals ai, or actually a1 here. Okay, the first attribute of a, and then if link dot find http. So if we find an http link higher or equal to 0, okay, we would actually like to display it, right? So we would like to print link, and in that way we're actually going to parse and print all of the HTTP links that are related to the web page that we access. So I will do new parse equals PyParser. Okay, and then I will do again new parse dot feed link. Okay, so this is going to be a recursive function because we call the function inside itself until we get the final result, or until the number of links finish. So here I will do URL equals to http youtube.com. Okay, then request will be equal to URL library dot request. Okay, dot URL open, and here I will write the URL that we pass to the program. Okay, then let's do parser equals my py parser. Okay, and then parser will be actually dot feed request. So as you can see here, we're creating object parser from the class PyParser, and then I will do request dot read dot decode, and then I will do UTF-8, and that's it. We're done. So let's save that. I save the file, and let's go back to the terminal. So I'll go to the terminal here, and I'll exit the Python mode. Okay, so here, since I'm in resources, if I write AOS, you can see the file actually I misspelled it, but anyways, extract links. So I will do Python extract links. Let's run it. And here you can see all the different pages that are related to the YouTube. So you can see we have the page about, you see the page about /press, about the /copyright, creators, ads. Then we also have the developers google.com YouTube. So you can see that this page is also related since YouTube is owned by Google. Then you have the politics Google, YouTube about policies, and so on. And finally, actually, we have this weird looking page. So let's put it in the browser and see what's inside there. So let's add the page, and this is how this weird looking page looks like. Apparently this is one of the main pages of YouTube. I never seen it before, but you can see that we can actually find and access every page that YouTube owns and displays to the users. So I hope, guys, this lecture was informative for you, and if that was the case, please continue watching the rest of the videos because they are also that interesting. Thank you very much for watching, and I will see you in our next video. Hello everyone, today I'm going to show you how you can actually extract images from a URL, which is quite fun. So the key here is to use two modules. One of them is called the RE module, while the other one is called the IMG module. Okay, so using these two modules will actually enable you to extract pictures from Python. Now let's go here to the IDE and create a new file, because this is going to be a runnable file, so Python file, and I write as name of the file image. Okay, so here we're going to write the code for extracting images, and let's start writing. So let's first access the Python folder by usr bin env. Okay, and then Python 3, and now let's write from url library dot request, and here we're going to import url open, and also I'm going to upload the url join. Okay, now let's also import the RE package. Okay, done. So let's create a function, and the function will be called download underscore page, and here we'll pass URL. Okay, we're gonna pass a URL, and we're going to download the page that is related to this URL. So let's write return URL open. Okay, so first we're going to open the URL, and I'm gonna pass here the URL. Okay, and then let's write a dot read. So we're gonna read the URL, then decode. Okay, and we will decode with the UTF-8. So we're done with this function, and let's create another one. So def extract underscore image underscore locations. Okay, and here I write page. So here we were going to pass the page from that URL, and I write img underscore regex equals re dot complete, and then let's write inside img. Let me actually get a bit closer. So here we write img semicolon plus src equals, and then I'll pass the following, comma re dot ignorance. Okay, so we're going to ignore these symbols, and that's it here. Then let's write return img regex dot find all. Okay, and I'll write here page. Okay, that's it. And then let's write if name equals main. Okay, and let me write underscores here. So if name equals main, and here we're actually going to run the function. So I write target underscore URL will be equal to http youtube.com, and then site will be equal to download page, and here I'll put target URL. Okay, so as you can see, we call here the download page function. Okay, so now from now on we have the page downloaded, and now let's write image location will be equal, actually image locations will be equal to extract image locations. Okay, so this is a function that we also created, and the page will be called YouTube. Okay, so let's write now for src in image locations. Okay, would like to print URL join. Okay, and then I write here target, where's target URL slash src. That's it. Okay, let's run now our code and see what happens basically. So here is a terminal, and let's write Python and then image.py. Okay, so here we can see that the name YouTube is not defined, or we don't have it. Oh, and this is because here instead of YouTube I had to write site. Okay, so that should be fine now. And let's run it once again. So the code ran properly, as you can see, but it didn't find any pictures on YouTube. So this might be because YouTube encrypts the images there in some way, or there are simply no images and everything is updated just from the users. So actually I'm going to put here my website, which is called Skilled Army. Okay, Skilled Army, and I know that I have images on it. So let's run the code once again and see if I'm gonna get some images. So now it's loading, and you can see that there are plenty of images here, and let's actually check some of them. Okay, so I'm gonna copy the link and I'm gonna put it in the browser. Okay, so here is the browser, and I will paste the link here. Okay, so you can see that this is an image from my website that you can see, which means that everything works correctly, and actually the images from my website are really imported or actually exported into our terminal, and we can see all of them. This is a very convenient way for you to check basically everything that is being uploaded to a website, all the images. So that's everything for today, guys. I think you learned quite a lot, specifically how to get images over network using Python. Thank you very much for watching, and I will see you in the next video. Hello everyone, today we're firmly going to talk about the URLs. URL means inform resource locations. And since the web exists, is basically fundamental for the way that the web actually operates. So pretty much URL represents a resource of a given host. So a URL can point to file, to a server, to resources that are related to that server as well. To work with URLs, you can simply use the URL library .parse module, and I will show you how it's done. So let me open a terminal here, and I write Python, so we can go into Python mode, and I write from URL library import URL parse. We got an error, and this is because we should import that from URL library .parse. Okay, so now we don't get error anymore, and let's write result equal to URL parse, and in the brackets let's write https www.youtube.com/about, for example. Okay, and then let's write result. So you can see now the parse result that the scheme or the protocol is the HTTPS, the location is youtube.com, the path is about, the parameters we didn't specify, the query we didn't specify, and we didn't specify any fragments as well. Okay, so basically we're using the URL parse in order to recognize different parameters, or basically what everything from the name of the website we want to access means. And if I write, for example, result.path, you get only the path, which is about. If I write result.net location, you can see that the net location is youtube.com. So in general speaking, all the resources in internet usually use the HTTP or the more secured HTTPS protocols or schemes. And in order to locate a specific resource, we usually need to know the TCP port, which is the transport port that the web page resides. And we also need to know the path to this resource. Okay, so for example, in our case the path is about, so this is how we find different pages within the same internet location. Also, I know that you've probably seen, and actually I'm gonna go back here to YouTube about, and if I write a question mark here and I write query equals, let's say, or actually let's make it more interesting, let's imitate a YouTube search. So if I write here results, okay, and then we do a search query that is equal to Martin Y, which is my YouTube channel, by the way, and we got an error here because I had to remove this. Okay, so now it's okay. And now here we're doing a search query, and this is basically what would you see if you simply do a search in YouTube with the header Martin Y. Okay, so for example here, if I write result.query, I will see search query. It's now set it up to be equal to Martin Y, and if I write result, I will see basically all the items here, and you can see that now on the query we will get that the query is search query and it's equal to Martin Y in that case. And so even I can go and add this in internet, but the only difference actually will be that I will add Martin plus Y. Okay, because this is how YouTube operates for the empty space. So let's go to internet and let's place this here, and you can see after I search for it, you can basically find everything you need, and it's like you're searching in YouTube Martin Y. So this is how, guys, you can basically assess and find the different queries or parameters related to internet pages. And thank you very much for watching that video. I will be expecting you in the next one. Hello everyone, today we're going to talk about requests, and basically the requests allow you to send requests to HTTP server and get responses and messages sent by the server when answering your request. Obviously we have the request package available in Python, so we can actually use it in order to access these requests. Let me actually go to the web page of this package, so you can see here that they're the request package, and from that page you can simply learn how to use it on docs.python-requests.org master, and here's everything that you need to know about requests, and you can follow these links to see the different functionalities of that library. But anyways, today we're going to do some examples, obviously. First of all, what you will need to do if you don't have it installed yet, let me go out of here. You need to install it by writing pipe install requests. Okay, and once you do it, this will be installed in your computer. I don't get the installation because my requirements are already satisfied, or the package is already installed in my computer. So the requests library pretty much automates and simplifies the tasks we were doing already, and I will show you how this is done. The main thing that we're going to use here is the get requests functionality. So here's how it works. Let's write Python, and here I will type import requests. Okay, and let's write response equals requests dot get. Okay, so now we're getting a request, and let's use here GitHub. So I'll write HTTP and then www.github.com. okay, and here's how we're going to get the request from the github.com. So now we did a request to github.com, and the response of this request is in the response message here. So we collect the answer from GitHub in the response. So if I write a response, you see that our response is 200, which means that the data was successfully, or the connection with GitHub was successfully completed. And if you want to see this in more clear way, you can simply write response dot status code and you just get 200. You can also do response dot reason and you will get OK, which means that basically everything is okay. Or you can simply do response dot URL and you can see the URL that we assessed, which is the github.com, and you can also do response dot headers, and then you can do content dash type, okay, and you can get the content type, which, as you remember, is basically the type of the page that we assessed. So it's text slash HTML. Actually, why is text and why is HTML at the same time? This is just because HTML is simply a text file with a code that is in HTML format. So the HTML format is the ones that the browsers are reading. So to assess the header properties here, you can simply do response dot request dot headers, okay, and once you do that, you can see that the user agent is python slash request, so this is what we use to assess it. Then acceptance encoding is gzip and deflate, and then we are getting the accept and the connection keys, and you can see their responses as well. So let's finally write response dot text in order to view the response in a different way, because you can basically look at it in many ways. So this is the way that you look at it as a text, and you can see how long is that text actually, okay, because not always the computer read languages are easy to be understood by humans. So this is how our response looks as a text, actually very long one, a lot of lines of code. But anyways, this was the way, guys, that you can basically work with URLs, assess them, and check different properties of theirs. That's it. Thank you very much for watching, and I will see you in the next video. Hello everyone. Actually, we're seeing my laptop with this ridiculous message here that we had left from the last lecture. But anyways, today we're going to talk about the HTTP headers and basically how to check them. So we're going to write some code. We're going to create a file and run it from the terminal. Now, what I'm going to do is to create a new Python file, and the file will be called g/header, okay, for get header, and we're going to use here the command response.headers in order to get the headers of the web service response. So you can see basically how we can assess the header response. Now let's first assess the Python folder, which is on user/bin/env python 3, and then let's import requests, okay, and let's create a response where our data from our request will be basically recorded. So I will do requests dot get, and here in the brackets I write http github.com, okay, and then we're going to do an exception here. So I will do try, and then for key value in response dot headers dot items. And I hope you remember actually how the headers were looking like. Basically they're a dictionary which has a key, and versus the key it has a value. For example, the key page has the value about, or the key URL address has a value, for example github.com. Quite simple. So for each key and value we're going to print %s, and then again %s, and the values that we're going to print are key and value. That's it. Okay, and then let's write except, and here we'll create exception as error. So we're going to display our exception as error, and we'll print. Now do again %s type, and here I write %error. Okay, let's save that and let's actually run it from the terminal. So let me open the terminal and I'll exit here the Python mode. Let's ensure that we're in the right folder. Yes, we are. So I will do Python g_headers. Let's run the file. And here we're getting an error. Let's see if we got error actually somewhere here. So I think here I missed the %sign. Okay. Let's run the file again and see if we're gonna get some error. So now it's loading. No, we don't get error this time. So now here you can see the script execution of the github.com, and you can see here that how the content is encoded, the transfer, the types of ranges that they have, and so on. Quite useful information for you. So this is how this works. Let's see now how we can make a proxy requests. So this is actually a very interesting feature of the requests package in Python, because it allows you to use a proxy or intermediate machine in order to make a request through the web. So to do that, you can go in Python mode. So I'll write Python, and you can simply write proxy equals, and then I'll write protocol. So protocol, and then I will close this parenthesis here. Then let's write IP, then port. Okay, and then some additional data. Okay, this is basically the way that you are making a proxy. I just missed here the parenthesis, sorry, the quotation mark, actually I missed it. So yeah, this is how you define it. Basically this is the key and there is the value. Okay, and the same is with the IP. So if I write on the response equals request dot get. Actually, before that, let me first import the request because I want the program to actually run, you know. Let's import requests. Okay, and then let's write HTTP underscore proxy will be equal to HTTP, and then I write IP address. Okay, and then I'll write port. That's it. Okay, and then we can do proxy directory will be equal to HTTP. Okay, and then we can do HTTP underscore proxy. That's it. Actually, let me put a curly brackets here. And this is because the proxy parameter usually needs to be passed in the form of directory. So we need to create a directory in order to pass this parameter. So when I hit enter, this one is accepted. And then let's do requests dot get, and then I'll write http youtube.com, comma, and then proxies equals proxy underscore directory that we already created. And this is basically the way that we're getting the proxy directory. And so this is everything, guys, that I wanted to explain you in that video. I hope it was interesting. Thank you very much for watching, and I will see you in the next lecture. Hello everyone, today we're going to talk about how to use the whois command in order to get some more information about the domain that we are analyzing. Information such as IP address, location, and so on. So let's create now one file which we're going to run, and let's see how we can actually do that. So you can actually do this from the terminal using the JSON, and it is quite simple. Let's write Python. So I write here import requests, and after that let's do response equals requests dot post, and here I will do http then slash http bin.org slash post, and let's close that here. Then I will do JSON equals key, okay, and then a value. Let's close the bracket here. Okay, so our response is completed with the post method, and now if I do response dot status code, it is 200, so it was successful. And if I do response dot JSON, okay, you can see all the arguments related to the JSON from here. So you can see that args, we don't have args. The data here is key slash value. We don't have files, we don't have form, we have our accepted method, and so on. So this is a way, guys, for you to use the JSON in order to check all the data. And as you can see, as I promised, here you can find also the IP address of this website here. And so this is the origin, and also you can find the URL, the root as well, and so on. So this was everything I want to show you related to the JSON and how to find information about websites with it. Thank you very much for watching, guys, and I will see you in our next video. Hello everyone, since you covered most of the topics related to how to send requests to a server and see some content from different URLs, today I wanted to talk about forms. In order to use forms, we need to look at the post method from the Python packages in order to submit a user input from HTML file or to upload certain files to the server. So when you use the post method, imagine it as a way to send data in the body of the request that we are making. And usually it's a good practice that when we put any type of data there, we can also add it in the content type header, so we know that we're working actually with forms and that our request is the appropriate type. So let me go now to the web and show you a website that you can get more information about forms. So the site is called http bin.org, and it offers you a test server that returns certain data once we make requests. So if we scroll down here and we go to HTML form, you can see an actual form that corresponds to the post method. You can see that here we have customer type, customer name, telephone, email address, then pizza size, so we have different bars here. Then we have selectable buttons, multiple choice, time field, and delivery instructions. So this is a pretty good example of how you can post a form into an HTML format. So for example, here I can type my email address and I can choose different things. I can choose a time, for example, and deliver instructions, and then we can submit the form. So let's do 11:45, and you can see that after we submit the form, we're actually getting the message that is released from that form. So we're getting the arguments, we get the header, and the header is usually filled with the information that we just added. So here we get the JSON equals to null, the IP address, and the URL as well. So this is the code that generates that form basically, and this is how it would look what we inserted in this form. So for example, if I check here the content type, you can see that the content type is the application www form URL len coded. Okay, so here we get the content type basically. So let's go now to the IDE and let's construct some request that is related to the forms. Let's write a terminal, and let me actually increase the size a bit. Okay, so just type Python. So after we're in a Python mode, let's write from URL library dot request import request. Okay, so now we imported the packages, the package request, and now let's do requeue, which is going to be our object, is equal to request, and then inside the brackets write http, and then let's write the name of the site that we just used. So it will be called http bin.org/post, data equals data. Okay, so actually I can see here that we didn't define the data type, so data is undefined. So for that reason I will write data equals URL encode, and then data directory dot encode, and then in the brackets I will simply write UTF-8. So let's actually here, since we get an error, to create the data dictionary module first, and then we'll continue with the rest of the code. So what I will do, I will write data dictionary equals bracket, and let's add some parameters to the data dictionary. Let's write customer, now write here its name Martin, then let's write the telephone of the customer, so customer telephone, let me put it in parentheses. Okay, and let's write 32,233 or 32, whatever, it actually doesn't matter, and let's write comma, size, and let's also add parentheses here, so the size will be large, and I think that's enough for now. Okay, and actually I noticed here, guys, that I just missed one sign, so I will just add it. Okay, so now we have the data dictionary, and let's now from this data dictionary to create the data file. So I write data equals URL library dot URL parse, or actually just parse, dot URL encode, and here I write data dictionary, that's it. Then encode, so we use here the encode function, and the encode type will be UTF/8. okay, that's done. And if you get an error here, this might be because we didn't add the URL library parse module, so just do import URL library dot parse, and then run the command once again, and that should fix the error. So let's now write from URL library dot request import request. Okay, so we import the request class, and now let's write request equals request, and then write the same thing, http slash http bin.org slash post, and then data equals data. Okay, so we again get the same issue, but I can see now why it is, because here I wrote date instead of data. So let me fix that, and if I run the same request, now we don't get any errors. Okay, so let's add the header, and I will write request dot add underscore header, and you can see automatically it appears. And now in the header I will write content type, comma, and then application slash x dash www form slash URL len code semicolon char set equals UTF-8. okay, and let's select enter here, so that's accepted. And now if you do a submitting of the request to the JSON, so I will do response equals URL open, and we'll open the request. Okay, so I'll write here URL library.url open. Okay, so if you get the same error, write URL library.request.url open, and then you'll be able to open actually the request. Then let's write response directory equals JSON.load, and then response. That's it. Of course, we need to first add a JSON, so I'll import JSON, and then let's run the same command, and you can see that now it's accepted. And if I do now print response directory, you can see that we're getting all the arguments that we previously added. So the customer is Martin, the telephone is 32232, and the size is large. Okay, you can also see that the header has the same attributes that we added, so everything seems fine. You can see also the IP address of the origin. So we actually created and filled a form into this website just through the terminal using Python. So this is how, guys, you can actually access and update forms on the web just from the terminal and using Python. Thank you very much for watching, and in the next lecture we're going to continue talking about forms. Typically, you would like to send some form encoded data, and to do this, usually you simply need to pass the directory to the data argument, And to do that, you can usually use the request library that you're now familiar with, just so it can take action into all the encoding and formatting of your data. So today we're going to create an example in which we're going to simulate sending an HTML data through post request. So this would be actually the same if you would go to the browser and send a form from the website, but this time we're going to write a script and then run it from our terminal. So to do this, you can use the request.post method. So it's request.post, and okay, I'm not typing here, request.post. So usually you can use this in order to send the forms, and specifically the put method. And I will show you now the whole syntax, and we're going to code this into the PyCharm. So let's create a new file, double click, new Python file, and the file I will call it forms. So let's write, actually let me make it a bit bigger, import requests, that's it. So after you import this library, and let me actually change this, let's create a file called data dictionary. That's it. I hope I didn't do a spelling mistake. But now what we're going to do is we'll write customer, that's it, and the name of the customer will be Martin again, which is my name, by the way. Then let's write custel, and let's put it in parentheses actually. Okay, customer telephone, and again 32 whatever, and then let's write a size. Okay, so we have the size set to large, and let's this time also add an email. So I will create a variable custmail, and the email of the customer, it will be, let's say, mail@domain.com. so any email would work out, and pretty much that's it. So after our data dictionary is created, let's create the response variable. So response will be equal to requests dot post, and here we'll do our post. So let's add the HTML that we used last time. So I write HTTP and then http bin.org/post, and then data equals data underscore data dictionary. Okay, so we already created and posted a request, and now let's actually print the status code of our submitted form. So let's write print, and in the brackets http status code, that's it, plus str bracket response dot status code, that's it, and then if response dot status code is equal to 200, and if you remember guys, 200 means that our action is accepted, then we'll print, okay, response dot text. Okay, so if what we say here is that if our status code or if our response is successful, then we would like to print it. Okay, so that's it. Let's save that. Okay, and let's go now to the terminal. So I will exit the Python mode, and let's now go to the folder that is our file located. So in my case it's installed in the resources folder, so I will just go to it. Okay, and now simply do Python and then the name of the file, which is called forms.py. So if I run it, okay, you can see that there is an error here, and let's see what the error is. So yes, here instead of resp I had to write response. Okay, that's it. Let me save it actually, and let's run it again. So you can see that, guys, after I run the file, you can see the form. So the form was created here in the data dictionary, and also on the next line we posted our data dictionary into this website. Okay, so we edited each of the fields in this website, and now we submitted the form in the website. You can do this actually with every website, and you simply need to create the file like this. And for example, if you always use certain credentials for registration, you can just create the form and change the link here. So you post and submit this form to every website that you visit just from the terminal and just with this file. It is quite simple and intuitive. So you can see that the HTTP status code is 200, and you can see the arguments that we actually added: the customer telephone, size, and email address. So this is what we completed, and then here we get the header section, which gives additional data. So you can see the content type, the host, which is the website that we assessed, the user agent, or with what type of tool we assessed this website, and also the trace ID, which is quite a large number. And finally, you can see the JSON, which is null, the origin, which is the exact IP address, and the URL, which we assessed, which is http://bin.org/post. So here is, guys, how you can create a file and submit form online over network. Thank you very much for watching, and we will continue in the next video. Hello everyone. In this lecture we're going to talk about cookies, and also in this section we're going to work with cookies, and you'll see how we can create and edit them using Python. But I first wanted to clarify for you what cookies actually are. So cookies are usually created by a website, and they're actually files with very small amount of data, and this small amount of data is always being transmitted between the sender, which is usually the user, and the receiver, which is the website. So what are cookies usually doing is they're storing your activity, or they're pretty much writing a history of your activity over server or over any other service. So then this service knows what is your activity, which pages, for example, you visited when you were browsing, and knowing that information, it provides to the server some additional data in order to personalize the services that you are seeing. For example, if you were searching in the past for sports equipment, let's say if you were looking for football equipment, then all the advertisements that you see online are going to be related to football equipment, because for example, Google will have this cookie that is exchanged with you, and in there it will be written that you search for football equipment. So Google will know that you're a person interested in that, and for that reason you will see the ads. And why you see personalized ads is just because there is a cookies that are being exchanged between you and Google or any other server or website. Also, if you are shopping in certain website, this is a way that you would always see your items in the shopping cart, in the virtual shopping cart of the website, and the items that you have are usually listed also in the cookies. So there are usually two types of cookies, guys, and the first type is the session cookies, which are opened and are existing actually only while you're having the browser opened. So once you close the browser, your current session in the browser, then these cookies are demolished and they are basically deleted. The other type of cookies are the persistent cookies, and they are staying for a longer time, and this time is predefined. It could be 3 months, it could be a year, and so on. They could be staying there forever until you delete your browser or throw away your computer. So the persistent cookies are actually the one that are controlling the ads that you see and the search results that you get. Of course, cookies have some quite advanced security options, so the data that is stored there, which is your data, is not vulnerable and is not sent to any other companies or users that shouldn't have them. For example, if you want to save your credit card information on your computer, then you definitely don't want this cookie to be accessed by anyone else except yourself. So, for example, some cookies, they can also store a login token, and this is specifically a cookie that will remain in your computer or in your account forever. And this is the way actually that in the recent years Google is so good at saving your passwords for different websites, and simply by logging into your Google account you have access to all your website logins, simply because they store the cookies for that logins specifically in your Google account but not on your computer personally. So before you think that cookies are a bad thing, they are actually the only way for the server to track the client and to give the information that the client actually needs. This is because the HTTP protocol does not actually a mechanism that can say if even two searches are coming from the same client or not. So without server being enabled to uniquely identify what a customer wants, then it would be impossible to shop online or having saved the password on our computer. So these are cookies, guys. I hope you understood them quite good, because in the next lecture we're actually going to do some coding with cookies on the web, and it will be quite exciting. But that was it for today. Thank you very much for watching, and I will see you in the next video. Working with cookies. Hello everyone, today we're actually going to be working with cookies, and I will show you some quite cool stuff that you can do just from the terminal. And in the end we're going to create a Python script that will run cookies as well. But now let's type Python and let's write some code here. So first I will import URL library, and then let's create the cookie processor. So I write cookie processor, and this will be equal to URL library dot request dot http cookie processor. Okay, so now we can see that the URL library has no attribute request. Let's add it, request. Okay, and let's run the same code again, and now it's accepted, so that's good. So let's now write from http dot cookie jar import cookie jar. Okay, so if you don't know what cookie jar is, this is the way that you can send your own cookies by creating a cookie jar object of the cookie library, and this will be as a parameter to the HTTP cookie processor initializer. So this is why we're going to use this class here. So here we just need to create object in the cookie jar class. Let's do that. So I'll do cookie jar equals cookie jar. Okay, so now we have this object from the cookie jar class, and let's write now cookie underscore processor equals URL library dot request dot http cookie processor, and then I write cookie jar inside cookie jar. That's it. and then let's write opener, or what will open actually the cookie, will be equal to URL library dot request, okay, dot build opener, and I write here cookie processor, and that's it. And the final line you need to do is URL library dot request dot install opener, and here I write opener. That's it. And we can use the opener so we can make the HTTP request. So let's write opener dot open, and here I write, let's say http www.github.com. okay, let's see what will happen now. So we wait a bit, and you can see that we've got the HTTP response client. So we successfully completed this action to open the GitHub page. So let's see the cookies that has been sent. So if I write len and then cookie jar, let's see if we have any items in that jar. So you can see that we actually have 3 items. So we received 3 cookies from the github.com. So since we have these cookies, now in the future, every time when we make further requests to this website, the HTTP cookie processor will use the cookie jar to check if there are any cookies currently existing. And if they are, the program will automatically use them in order to personalize the use of this website by us. So we now know that we have 3 cookies, but let's see what actually those cookies are. So I write cookies equal list, and I write cookie jar. Okay, so here we'll create the list with all the cookies that we have in the cookie jar, and then we would like to display this list, so simply write cookies. So you can see now we have plenty of information, but there is one specific very important information, and there is the cookie information. So if you see here, here is the name of the first cookie, which is called login. Then we have another cookie which is called ghsys, and we should have a third cookie. Let's see where it is. If you can find it, that'd be great actually. And yes, actually I missed the first one, but it is here in the beginning. It's called octo. So these are all the cookies. We can also see a lot of information related to the GitHub port, and basically you can see how much information we're getting per cookie. Quite a lot, isn't it? So this is the second, and this is the third. So you can actually see that in some of the cookies, for example this one, has the HTTP only flag, which means that this cookie, so in that case this cookie cannot be accessed only from the HTTP client, but also from all other clients, you know. But if this is equal to true, this means that the cookie can be accessed only from the HTTP protocol. So usually it's good that this cookie it's equal to yes but not to none, because if the HTTP only is on, this will prevent the cookie from the cross-site scripting attacks. Another important feature is the secure flag, which is also very important for the security of the cookie. And you can see that here in all the cases the secure equals to true. So this means that even though the HTTP only is equal to none, this cook is more secure, and you shouldn't be worried that your data is, for example, vulnerable. So let's write now one script in order to extract cookie information. So let's create a new file, and I write, okay, not file but Python file we need. So Python file, and I write cookie. Okay, so let's write here import http dot cookie jar,
And then after this, let's import URL library. Let me remove the warnings here. And then let's write URL, or this will be the URL that we'll be using, will be equal to https github.com. Let me get closer. So let's write a function now, and this function will extract the cookies information. So I will name it extract. So let's write here cookie underscore j for cookie jar equals to http dot cookie jar dot cookie jar. Okay, so this is an object. Cookie j is an object from the class cookie jar, and let's create an opener, okay, which will be equal to URL library dot request dot build underscore opener. And actually let's import the URL library dot request. Okay, so we can recognize this, and now if I write a dot, then we should see the build opener. That's right. And inside I write URL library dot request dot http cookie processor. That's it. And then cookie underscore j. So now we created our opener, and then let's write response equals opener dot open, and then the URL that we used. That's it. And then let's create for. So here we're actually going to print the data. So for cookie in cookie jar print, let's write cookie and then %s, then again %s, and the s is going to actually be, okay, let's put here cookie name and cookie dot value. Actually here I removed the comma because it's incorrect, and also here I missed the column. Okay, so now everything is fine. So let's now, if this loop is exited, let's print. So print headers s, and then let's write resp dot headers. Okay, so let me save that. As you can see, the code is accepted, and let's go to the terminal, run it, and see what happens. But actually, wait, I forgot the final statement that will run actually the function. So I will write if name equals main, okay, and we'll run the extract function like this. Okay, so let's go now to the terminal. I will exit the Python mode, and let's write whois, so we can see the cookie file. So I write python cookie.py, and let's see. So we're getting an error here. So I can see the error here, guys. I wrote GitHub instead of GitHub. Let's fix that, and let's try to run the code again. So we're still getting an error. Let's see what it is. So here I forgot to add the brackets after the cookie jar, obviously, because it's a function. Let's save it now, and let's run it from the terminal to see if it's gonna work. And you can see now that everything works. So here's how you can obtain cookies from a website directly. So you can see here the set cookie code. Okay, and basically the same cookies that we saw previously are now displayed, but just the cookies here from this website github.com and are displayed via script, but not by simply writing commands in Python. So when you run this script to github.com, you're going to get all this information. And this actually accounts for every website. For example, if we do youtube.com, you're also going to be able to see the cookies from this website as well. So if I run again python cookie.py, you see that here now the host is different, the domain is different, and you can see the cookies that are tracking my computer from youtube.com. So here is one of them, here is second one, then there is a third one, the set cookie. So we have visitor info live, domain, express, and so on. And you can see that they're about, okay, I think they're even more than 3. So there are actually quite a lot of cookies, as you can see here. So we have the GPS signal set to 1, the visitor info live, we have all the headers here, and then all the cookies. So whenever you want to check if a website is tracking your data, for example, you might want to remove cookies, check this script and simply update the domain. You can even make the script even nicer by allowing the user to write the domain that he desires. For example, URL equals to input, and then I will write here, write a URL, and let's save that. So when you run the code now you're asked to write a URL. So for example, I will write, let's say, http google.com. okay, and after I press enter, I will be able to see all the cookies that are tracking me from Google. So if you create the code in that way, every time that you run the code, you will be able to write the website and check the cookies that are currently on your computer from that website by sending the request and receiving the response. So this was everything, guys, I want to share with you about cookies. It's very important to know them because the data security and information exchange between you and the other servers on the network is quite important. That's it. Thank you very much for watching, and I will see you in the next video. Hello everyone. Since the cookies topic is quite interesting because everybody is interested about how his data is exchanged over the network, I decided to make another video which will show you how you can handle cookies using requests. So let's create a request to obtain some cookies. So I will do response equal, actually let's go in Python mode, so I write Python. So let's first actually import URL library and URL library request, and also I will import http dot cookie jar, and let's write import requests, and then session equals requests dot session. Okay, so here we're creating a session class in order to observe cookies from a website. But from which website we would like to observe cookies? So let's write the response equals request dot get http github.com that it is, request is not defined. Yes, so let's do then URL library.request. So then I will do requests. Yes, I think that's gonna be accepted. That's it. It took some time, but now it's good. So let's do now print and then response dot cookies, and you can see that now we're able to print the cookies from github.com, and you're already familiar with the cookies that we have from there, such as the logged in, which is now set to no, and the rest of the cookies like ghsess and so on. So let's go back to the session. So let's print session dot cookies dot get dictionary. Okay, and then let's do response equals session dot get, and now you can see in the first example we couldn't print any type of cookies simply because we didn't pass any domain to the cookies. But now let's write here in the brackets http github.com. okay, and now let's do print, then session dot cookies dot get underscore dictionary. Okay, and I think that should be fine. So you can see that this is another way that we can actually print all the cookies, which is an alternative to the first one. So you can either do it with the get method or with the get dictionary from the session. Okay, and so here we're using the get method in the same way as we used it in the requests.get, but this time we're using the class session in order to receive the cookies from the website. So let's go now back to the IDE, to the PyCharm, and let's create a new file, and the file will be called get cookies. So let's create a new Python file actually, and this file will be called get cookies. Okay, and let's write it. So now let's do so this file is basically going to extract the cookies in a very nice graphical user interface from github.com or from any other domain. So what I'm gonna do is first I will do the Python directory, so user bin env python 3, that's it, and then let's do import requests. Let's remove this warning here, so syntax, that's it, and let's write a function. So def check http only, okay, c, and let's write if http only in c dot underscore rest dot keys return true, and then let's write else return, and in our case let's ask to return this code. Then cookies equal to a list, so we're creating a list from cookies, and then I will do URL equal to http github.com, okay, and then response will be equal to requests dot get, in the brackets URL. Okay, so here we're getting the we're sending requests to the github.com and we're getting the response. And now let's write for cookie in response dot cookies. Let's print first name comma cookie dot name, and then let's print value, comma, cookie dot value. Okay, and finally let's write cookies dot append cookie dot value, and then if not cookie dot secure. So if the cookie is not secure or it doesn't have the secure code, we would like to cookie dot secure equals false, and then I will do print HTTP only, comma, and then you can do check HTTP only, and we'll check this for cookie. Okay, because we're still in the for loop, so for every cookie we're going to check if it is HTTP only, and let's write here n, actually backslash n, so we go to a new row, and that's it, guys. Let's save this code and let's go now to the terminal where we can run it. So I'll exit the Python mode and I write ls, so you can see that the file get cookies, actually I wrote it got cookies, maybe because I'm filming for already about 1 hour and a half, but let's actually run the file and see if everything is correct. So Python got cookies, and we have some error here. Let's go back to the code and try to fix it. So here is the error, guys. Here is cookies instead of cookie, and this is why we've got this, that cookies is not defined, because it was actually not defined, but now it should be fine. Let's save it and I run the code again. So now you can see that we're getting all the information that we requested. So for this cookie we get the name, which is logged in a very nice graphic, so you can easily distinguish it. Then you get the cookie value, which is no, and then you get if it is HTTP only, which is here false, so you can see that here. And after that you can see the actual cookie, and again the HTTP only, that is equal to false, which is exactly what we wrote in the code. So let's write here print set and cookies. So if I run the file again, you can see the difference, that we see more than one cookie at this time. So here we see the set of all cookies, and on the top we see the logged in cookie with the information that we desired. So that's it, guys. Thank you very much for watching. This was actually quite an interesting lecture. Hi everyone, today we're going to talk about authentication, and I will explain you what it is, and then we're going to, of course, do some Python tests and write scripts in order to do authentication with Python. I guess some of you might know some things about authentication, but the most simple way to explain it is, for example, sometimes if you want to log into your account, you would need an authentication app in order for you to have two-way verification of your access. So this is a more secure way to access your web credentials over the web or over the network. Authentication supports natively HTTP protocols, and it accepts both types of HTTP, the basic HTTP and the digest HTTP. So the basic HTTP authentication is based on the base64 protocol, and usually is composed by two things: user and password. And this is your username and password. You know, you can always see your password written by dots, so you cannot actually see what you're writing. So the authentication mechanism is just the way that you're seeing your credentials, and it defines what is password, what is username, and so on. The other HTTP mechanism for authentication is the HTTP digest mechanism, and this mechanism uses MD5 encryption protocols to encrypt the user details. With Python, it is actually very easy to access authentication modules, and you can do this usually with the request library, and from there you can access both the basic and the digest authentication algorithms. So let's first talk about the base authentication. The base authentication assumes that the client is identified only by username and password. So in order for the client to access the website or the page over the web, he needs to provide both of those credentials in order to do that. So once we request the server to log in, the server usually responds with the connection to the base64 encoding and gives you the fields where you can write your credentials, or as we said, username and password. On the other side, the digest authentication is created after the base authentication, and it is usually used to improve it. It usually encrypts all the information with an algorithm called MD5. It uses a key and realm in order to encrypt your data. So the digest authentication extends the basic one by using one-way hashing cryptographic algorithm in order to protect your credentials. So it first encrypts the authorization information, and then it adds a unique connecting value. This value is used by the client browser in order to calculate the password response in a hash format. So your password is not directly related to you, but it needs to be calculated by the algorithm and returned. This adds extra level of safety while using your credentials. So this was the introduction to the authentication mechanisms, and in the next lecture we're going to assess them by using Python. That's it, guys. Thank you very much for watching this video, and I will be waiting for you in the next one. Hello everyone, today we're going to try it out some of the authentication mechanisms that we were talking in the previous lecture, and you can see here that I have the terminal open as well as the PyCharm opened in the back. So we're actually now going to work with the PyCharm, and here I'm going to create a new file, and let's select new file, and I will say BAC out for basic authentication, and let's write our code now. So I'll write to access the Python folder user bin env4 environment python 3, and then let's import requests, and then from requests dot out import HTTP, and here, since we're doing basic authentication, we will import basic out, and let's write now requests dot get, and here we'll get the URL and the parameters. So okay, let's work again with the github.com. So I'll do HTTPS, and we'll access the GitHub user login page. So it is API dot github.com user, and then let's add the authentication credentials. So I'll write out equals to HTTP basic authentication, and here I write user, and then I will write password. Now let's create our response from the server. So response equals requests dot get, and in the brackets let's write HTTPS, and I write API dot github.com slash user. Okay, so the same thing, and then I'll write out user comma password. That's it. Okay, we're ready here, guys. And after that, let's do the print statement. So print, and let's write here response dot status code. So first we would like to see the status code plus, let's create a string str response dot status code. Okay, so here obviously we're going to print what is our status code, and then let's write if response dot status code is equal to 200, or if everything is accepted, then we would like to print that the login is successful. Okay, and plus response dot text, and also what the response says. Okay, so let's run this code now and see if it's gonna work. So let's do whois here, and let's see, there we go, Python and then bas authentication.py. So let's run this file, and here we get an error, so let me check it. Out is not defined. Let's see. Yes, so here I didn't write the equal sign, so maybe this was the issue. Yes, let's run the code once again and see if it's gonna work. So you can see that the response status is 401, and what that means, guys, is that our authentication is not being accepted, right? So our login is not successful here, and this is the code that you usually see when you couldn't log in that case. So our code works, which is good. So this is how you do the basic authentication, and this is what gets returned. Let's now try to do the digest authentication. So let's do Python to go into Python mode, and I'll import requests. Okay, and then from requests dot out, here we will import HTTP digest out. Okay, so this package exists and is now imported. So let's do now response equals request dot get protected URL, comma, out equals HTTP digest authentication, and here we can write user password. Okay, let's add another bracket. Here we've got an error, so the name request is not defined. Okay, so we need to import the requests instead of request, so requests.get. Then instead of the protected URL, let's write the GitHub login page. So as you can see, guys, it doesn't work with the API github.com user that we used previously, and for that reason we need to use another website, because obviously this one doesn't support digest authentication, and for that reason I use this one, http bin.org digest authentication user pass, and from that website you can actually obtain the authentication. And the only thing I will need to do is to do, instead of basic, digest authentication, and when I run it you can see that the input is accepted, and if I do response you can see that we couldn't log into the website, however we were able to send request to it. Let's now try doing this from a script. So I will create a Python file here, and it will be called digest authentication. Okay, and let's write user bin env python 3, and then let's import requests, and then I will do from requests dot authentication import digest authentication this time. So let's write URL equals to http bin.org, and then let's write digest dash out, and then authentication user pass. That's it. Let's get a bit closer. Okay, and then let's write response equals to request dot get, and then we want to get the URL. Okay, and then I'll write out equals http digest authentication, and here I'll write user and then password. That's it, and then let's write print, and so let's print response dot status code plus str, and then I will do response dot status code. So this is what we're going to show here, and then if response dot status code is equal to 200, then we will say, so we will print, okay, login successful. Okay, and I will add here str response dot json, and that's it. So if we log into the website, then we will display the response.json. So we will actually say that the login is successful, and we will display the credentials. So let's save that, and let's see if the code is going to be accepted. So I'll go out of the Python mode like this, and then let's write ls. So you can see that now we have the digest authentication file right here. So I will do python digest authentication py, and okay, I can get that. We are getting an error here, so let's see what could it be. So obviously here there is no comma. I'll remove it and try it again. Let's run it. So you can see that now, guys, we got the response status to 200, and so our authentication was successful. So we've got the user, you can see that now, and we can see our credentials for the login. So we successfully did it, and we logged into this website. So that was it, guys, for this lecture and for this section. Actually, you learned quite a lot of things in this section, such as cookies, how to assess websites, get response from them, how to do the authentication that you saw just now, which I'm sure is quite useful for you, and you're already getting some experience on how you can connect and execute code over the network using Python. So thank you very much for watching these lectures, and I will see you in our next section.